Okay, with all due respect, please welcome Dr. Tajul. Okay, Dr. Tajul, the stage is yours.
All right, Assalamualaikum and very good morning to all. First of all, I would like to say thank you to the moderator, Mr. Nazwan. All right. Thank you as well for Mr. Hafiz for a very interesting presentation. All right, before I start, I would like to take this, to say thank you to the organizer for this opportunity. So hopefully I can share something to this webinar. Can you guys hear my voice? All right, thank you. All right, so, okay, let's start the sharing session. So today's talk is, I would like to share a little bit about, the title is about fuzzy logic system made easy with FuzzyR Toolbox. Okay, so what is a FuzzyR Toolbox, right? So the FuzzyR Toolbox is a toolbox that we created under the R programming. So hopefully by using this toolbox, we can easily construct a fuzzy logic system. All right, so outline for my presentation today, I would like to share a bit about my background, some AI introduction, fuzzy logic system, and some of examples that have been created using FuzzyR Toolbox. So I think the background is already introduced by the moderator. I I did my bachelor and master degree in University of Utara Malaysia, and then PhD in University of Nottingham. So my research area is on AI, fuzzy logic system, and decision support system. All right, so let's go to this before we start to the toolbox. All right, so let's have a look on the state of the arts of AI. So artificial intelligence. So what is artificial intelligence? So it's a combination of artificial plus intelligence. Okay, so we got the AI, artificial intelligence. So by definition, the AI is intelligent exhibited by machine rather than human or other animal. So in easy word, right? So the AI, artificial intelligence, try to mimic how the human give a decision, how the human give a reasoning, okay, in order to solve the problem. All right. So what is AI? So AI, computer machines, right? The aim is to solve the problem, all right, or to give the decision. Like how human give a decision, how humans do a reasoning, right? All right. So of course they will require intelligence element. So they have a lot of type under AI. Okay, for example, my colleagues, Mr. Hafiz already presented about, a bit about a deep learning. So, under branch of AI, they have a lot of things. So these some of the example. They do have machine learning, neural networks, robotics, expert system, fuzzy logic system, natural language processing, and also deep learning. So my presentation is more highlighted on these fuzzy logics, okay? Specifically, how to design the fuzzy logics using the FuzzyR Toolbox. So yeah, AI is been popular nowadays. So it has been used in many fields, many areas. For example, healthcare, transportation, education, social media, and etc. So we in our research group, okay, me and also Mr. Hafiz, we are under the research interest group, the same. This is what we call deep learning group. So we conducted a lot of our AI project. They are more on predictions, forecasting, medical diagnosis, recommender system, decision support, and intelligence system. So we try, some of our publications. There are various area in education, medicals, agriculture, military, and also etc. All right. So now we are moving forward to fuzzy logic system. I think in this webinar, in some of the participants, I think they already well known about fuzzy logic system. So let me give some of idea on fuzzy logic system. Maybe some of you not familiar with the fuzzy logic system. All right. So I have a journals that publish on this area. If you have interested, so maybe you can have a look on this paper. Okay, so fuzzy logic system become popular in modeling with uncertainty and impression information. When you have some of the issue, the problem that involve with uncertainty, so fuzzy logic system is good to be used in order to solve this problem, right? Here is the components under the fuzzy logic system. All right, they have we get the Chris value, Chris input, and then we pass to the fuzzy component that involve fuzzifier that convert the Chris to the fuzzy sets, and then they have a fuzzy inference that will join together with a rule base, and then from here they will defuzzify to the end result. They are converted back to Chris output. Here's an example of temperature. In fuzzy logic system, they represent the input into this they call membership function or linguistic term. For example, for the case of temperature, so they divided into three categories where there are colds, normals, and hot. For example, if the temperature is 40, so they are fall into the cold. So we can say that with the 40% of temperature, there is a cold, right? And so on. All right, and then they have fuzzifications, all right, in the fuzzy inference application. So they can either use min or max, in order to get the final result, final evolution. All right, I will not go detail into this fuzzy logic. I will just go surface to give some idea on this fuzzy logic system. So because of this, fuzzy logic system are good in provide some interpretables or interpretability, and also provide a key building blocks. All right, this is because it is due that when comparing to the black box model, so fuzzy logic is a claim that they are good in terms of providing some explanation, because in the component of fuzzy logic system they have clearly very transparent what is happened inside the box. So they claim this is a white box, so they are more explainable. All right, so this is to do, in fuzzy logic system, they use the linguistic variables and linguistic rule, in linguistic variable and linguistic rule, they are very nature, they are more close to the human nature, all right, so it's easy to understand. Here is the element how, from fuzzification until defuzzification, They have three main component: fuzzifications, inference engines, and defuzzification. I will not go deep into each of component, but just to tell you, they are here what happened. So we know what happened under in the white box of fuzzy system. All right. So I saying about uncertainty. So in our life, in real life, we are dealing with a lot of uncertainty. This is example. For example of the age. The age is become every day become growing. So for example, what age are you define old? What age that we define old? Right? Maybe a person A will say, the age they define the age old is between 50 to 60. If you're more than 60, maybe you're very old, right? But person A will say that the range of old is between 50 to 60. If I ask another person, so they will give a different input as well. For example, the person B might say, oh, for the age of old, they define that between 55 to 65. All right, so they have uncertainty or the subjective answer here. And if I ask another person, they define the old is in different range. For example, between 48 to 58. This is just answer that obtained from the three people. So here they have a uncertainty between the answers. So how can we really define what is the age of to define old? So here the fuzzy logic is very good to capture this uncertainty. So we can obtain all the input from three people, so we can get all the uncertainty, and then we introduce here is the membership function of to present age of old. so that we capture the three answers from the participant that given the answer of a range of all. So here we get the final example, final membership function that will represent all. So the under the orange color we call it FOU, the food of uncertainty. That is under type 2 fuzzy. Now I just want to show you the example, a simple that how the fuzzy can capture the uncertainty in the real case. All right. So actually, the talk is more on toolbox, okay, fuzzy toolbox. But before I want to show the FuzzyR Toolbox, it is good to show the example of fuzzy toolbox in MATLAB, because the idea is, I think most of people know, if you are working on the fuzzy logic system area, I think they are well known about the toolbox under MATLAB, right? So I think that is a good idea to to give some brief idea to refresh what is a toolbox, fuzzy toolbox in MATLAB. So here is a MATLAB interface. Mr. Hafiz, can you see the screen? Because I just changed from PowerPoint to the MATLAB. Nazwa?
Oh, yeah, you can see the screen.
Okay, thank you very much. Okay, I just want to demo a bit. Okay, if you want to see the FuzzyR Toolbox, you have to type fuzzy. And when you click the, enter, so here is the fuzzy logic toolbox under MATLAB. So they have input, they have Madani rules to how to input rules, and they also have an output membership function. Okay, it's okay. So I just want to show example of a tipper problem. Okay, tipper problem, if you go to the restaurant and then you order some food, and then how good do you want to give a tip to that restaurant? All right, so let's see the example of a tipper problem. Here is an example of fuzzy logic system on tipper problem. Okay, so they have two input, service and food. All right, and then lastly, they want to give what is the tip to the restaurant. Okay, if I double click here, all right, so the tip is, okay, whether the people, the customer want to give the tip, whether they are cheap, average, or generous, right? Based on the service, okay, service, whether that restaurant have service, the poor, good, and excellent, and then the food, whether they are recent or delicious. So based on two input, and then they will give the final output, that tips, whether the tip is to give that restaurant chips or average or generous to that waiter or waitress, right? So here is the fuzzy toolbox in MATLAB. I think most of people that are working on the fuzzy area, I think they will know this interface. This is a fuzzy logic toolbox in MATLAB. Okay, and then you also can make sure the rule viewer. For example, if I give the service is for example 6.39, and then the food, let's say I give the food is very delicious. So the final tip is between average and generous here. Okay, so if you're looking here, they are more and generous, the tip here, right? So the final defuzzification result is 20.2. This is a fuzzy toolbox in MATLAB again, right? And then you also can see the rule, right? The rule. Okay, for example, in this case, they just only have three example of rules. Okay, for example, if the service is poor and food is a racist, then what is tip want to give? The tip is cheap, right? So they have a three rule. So the tipper example is very basic that inside the MATLAB. Okay, I think some of if you looking on the paper, there's some of them just to show the tipper problem, just to show very simple example of fuzzy logic. This is all on fuzzy logic toolbox under MATLAB. Okay, I just show to give some idea, because later on I will show how can we easily create also the fuzzy, something like fuzzy toolbox in MATLAB, but we are created in R under FuzzyR Toolbox. All right, so let's get back to this presentation. Okay, so some of our demo, okay, just to give some idea on the toolbox in MATLAB. All right, so I think it's good to also introduce now in R. Okay, this is RStudio. Okay, if you want to use R, just type in the Google. Okay, there's a very open source. Okay, different between R and MATLAB. MATLAB is a licensed software, so the organization, the company have to purchase to have a license to use the MATLAB. Yes, MATLAB is very powerful, but you have to purchase. Here is open source software, the R programming. Okay, and what I shown in the screen is about the RStudio. Okay, you have to install R, and then after that you can install RStudio. This is the interface, okay, of the RStudio. Okay, on the left here is a console. So for example, let's say I do y equal to 2. Okay, so they will send the value here in the environment working memory, and then z equal to 2. Right, so you can type in the consoles and they will return the answer here. And then C equal to y plus z. Okay, remember? So now C, you got a value of 4. This is a R, okay? This is a consoles, and then here's the environment, working environments. So they have history, connection, and also some tutorial. Okay, the environment. On the bottom right hand side, so here is a file, plot, package, and so on. Okay. So what I want to show is under the R programming, they have a FuzzyR Toolbox. Okay, fuzzy logic toolkit for R. Okay, if you click this one, but before this, okay, you need to install. Okay, you need to install this FuzzyR. Okay, how to install the FuzzyR? All right, if you look it on this RStudio under package, all right, so you can click install. Okay, they will link directly from our repository C.Chen. C.Chen is all the toolbox under toolkits under R is embedded into the historic to the C.Chen, right? It's like a server of R. So you have to type FuzzyR. Okay, you can get FuzzyR, and then you click FuzzyR, and then you click install. For my case, I already installed. All right. So I just want to show you guys, this is a FuzzyR. Okay. So in FuzzyR, okay, they have a lot of function. For example, in this FuzzyR, okay, you also can use unfizz models. Okay, how to insert membership function, how to insert rule, how to insert variables, and so on. How to evaluate the fuzzy fizz and so on. In this FuzzyR also, we created also, we provide some of element under unfizz, okay? Artificial neural network plus fuzzy system. So you can also use FuzzyR. Here is some description on this FuzzyR, okay? The version is now is 2.32, okay? The author of this package is Chow, is my colleagues, okay? The postdoc in University of Nottingham now. And then John Garibaldi is my supervisor, and also I contribute also in this toolbox. So you can read here some of description on this FuzzyR, right? And then you can also look it on this website. We provide some example. All right. So just now I showed about example of tipper problem using MATLAB. Okay. Here also we do have a tipper in R, right? So this is a tipper problem. In this example, we can run the example, right? For example, if I copy this one, the code, I copy and then I put on the consoles, and then I just click enter. Okay, error in tipper. Could not find function tipper. Why? Because let's go back to this package. We have to check the FuzzyR. Okay. After I check the FuzzyR, so they include the library of FuzzyR. And then now I copy again this code, and then I click paste and I click enter. So now we can evaluate this tipper case problem. All right. How to see it? So I provide in FuzzyR Toolbox, okay, one of another special under FuzzyR Toolbox. So we provide the GUI, okay, graphic user interface to show to illustrate all these membership function, rule base, and the fuzzification as well. Okay, so you can use the show GUI function, right? And then I click Fizz. Okay, so here is interface of now after we created the fuzzy logic system type problem, so we can illustrate it using FuzzyR Toolbox using the show GUI function. All right. For example, in this problem as well, they have two input, okay, and then one output, and then the input output they also have service. Okay, this is a service membership function for service, for food, and for tips. The same that we try to replicate the same case problem, type of problem under the MATLAB. But now we transfer into R Toolbox. Okay, so we can also visualize the rule base. Okay, the rule base, and then also it can be fuzzified. Okay, remember in in MATLAB. Okay, I provide example of rule viewer. Okay, this is a rule viewer in MATLAB, but also in R, we do have something like this. Okay, we call evalfis. Okay, let's give some example. Let's say here we give a service 5.5. So I created 5.5, something like that. Okay, and then the food we give, 799. 799. Okay. Okay, so they give the same result. Okay, 19.3. This is because 7.9, this 5.58. They have two decimal place. Here I just put one decimal place. But look at on this end result, differentiation. So they give the same result. Okay, and also for the case of we want to download this plot, so we can also download it, export into the PDF, right? Okay, the same with the membership function. We also can download the plot. Okay, it's a very nice plot that we can put into our article.
Berdua.
Sorry?
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 Ya, rumah ya, yang budak tu bang.
Okay, all right. I think, all right. So here is the example on FuzzyR Toolbox. Okay, but also we provide some of extra. For example, I call type2, a type GUI tool, right? Just to show you some of example. Another example of this. Oh, sorry. Okay, in the type2, I just to modify that in membership function. If you want to learn about fuzzy, okay. So for example, this is the membership using a trapezoid. So this is a Gaussian, and then this is a triangular. For the case of you, if you want to learn, okay. For example, if I choose Gaussian and I want to modify the pool, the linguistic term pool. So if I create here, they will dynamically change the result. Okay. This is just a matter of you want to learn how exactly graph, if you put sum of mean and spread, how to generate. So in this example also we provide, okay, and then you can change, for example, to see triangle, trapezoid, and triangular. We just take a three membership function example. All right, so you can have a look, okay, try and error, just a very interesting and dynamic. All right. Okay. All right. I think there is some of basics in in Fuzzy R Toolbox. Okay, so maybe you can have a look on this R Toolbox. Okay, fuzzy logic toolkit we call, because they have a lot of function that you can use. All right, in fact, you can use the NFIS. Sometimes we use NFIS together. To do the optimizer and everything. You can have a look in this one, and then we create also fuzzy accuracy. Okay, using the fuzzy accuracy, you can simply check the accuracy. For example, right? For example, if I create here copy, and then in R they have an example, so you can copy and put in the console, and then can try have a look this result. Okay, in the fuzzy accuracy, you don't need to worry about what is the MAE, RSMAE, MASE, and everything. So they have a lot. They have I think 8 error evaluation here, right? Okay, there is a little bit on fuzzy R in R programming. Okay, let's go to my slide. Right. So okay, I show some of to get a feel about what is a fuzzy R, what is a fuzzy toolbox in MATLAB, what is a fuzzy R in R. Okay, they are the same, but you can have a choice. Okay, if you want to use MATLAB or if you want to use fuzzy R. Fuzzy R is under programming R, it's open source software. In MATLAB you have to have a license and in order to use that. Okay, here is an example that I created some of fuzzy using FuzzyR Toolbox and already published. Okay, here is example of iris flower. All right, so under fuzzy they have a lot of toolkit or toolbox. Just now I showed about the fuzzy toolbox in MATLAB, and most of them is to create a fuzzy logic system. It's a bit in this paper we also show the step by step how to also you can design another fuzzy they call hierarchical fuzzy system. Okay, here is a fuzzy toolbox. Just now I show what is the interface of fuzzy R in R programming. Okay, so by definition is fuzzy R is an open source software based on R programming language. They offer ability to design the standard of fuzzy logic system. So the toolbox is already presented also in this conference, Fuzzy IEEE conference 2020. If you want to look detail on that explanation, maybe you can have a look on this paper. So why I open the fuzzy toolbox in MATLAB? Because in fuzzy R, the command line, the interface is quite close to MATLAB fuzzy logic toolbox. So if you are familiar with the fuzzy logic toolbox in MATLAB, so it will be easier for you to also use the fuzzy R in fuzzy R programming. Okay, all right. So this fuzzy R toolkit toolbox, okay, is already you can download this one under this URL. Okay, here is how to design fuzzy R. Okay, fuzzy logic system using fuzzy R. So for the case of iris classification problem, so we have 4 input and then we have 1 output. Okay, sepal length, sepal width, petal length, petal width, right? So here is our case study. So we would like to design in fuzzy R, right? So I just show the some coding. Okay, step 1, step 2, until so on. Okay, in R programming, all right. So first step is you have to load the library. Okay, library fuzzy R. Okay, step 2, you need to initiate the fuzzy model. Okay, using this function, a new fish, right? Don't worry about it. I can share the slide after this. Okay, after you create the fuzzy fish, fuzzy model. So next step 3 is you have to create input-output variable. Okay, for example of this iris, so the input will be 4 input. Okay, sepal length, sepal width. Okay, then the output is flower. Okay, and then you have to also set what is their minimum and maximum value of this membership. Okay, in the variable. Right, and then step 4, you have to create membership function for input and output variable. Okay, using this add mf. Okay, if you look it on the fuzzy R, Okay, I showed just now, they have a lot of function. So I highlighted only what is function. Okay, for example, for create info output, you have to use add var function. If you want to use, if you want to create membership function, so you need to use add mf function, right? For example, input small, this small, and then this a medium, and then this is a large. Okay, you know, in MATLAB, in FuzzyR, you can also drag drop, okay, to get what is the exactly value. All right, just now. And then, yeah, step 5 is create the rule. Okay, create the rule is something very similar to MATLAB. I think maybe MATLAB is the interface is very nice, but you know, if you have a code in MATLAB, actually you can transform into FuzzyR. It's very easy because they have the same structure. So you need to add the fuzzy rule using add rule function. Okay, here is for example, again, 1, 1, 1, 1, what is the meaning? Okay, if the supply length is small and supply width is small and fertile length is small and fertile width is small, then, okay, then the flower is Sentosa. That is the meaning of 1, 1, 1, 1, okay? And then step 6, you also can evaluate, okay, evaluate the fuzzy inference system that has been created for this iris. Okay, to use this, we may use the function of eval fish. Okay, let's say what is the value that we want to evaluate, we can give to this function, or we can use the slider using the GUI function. And then, yeah, the last, after you completed the code, and then you can evaluate using or illustrate it using the GUI. Okay, here just now, the example of iris. Okay, here is a membership function. Here is their fuzzy rules. And here is a evaluation fuzzy inference system. Right. So now is another type of fuzzy. It's called hierarchical fuzzy system. So they will decompose, okay, the standard fuzzy into the several of subsystem. Okay. By general, if we use the hierarchical fuzzy system, so we can reduce the number of rules. Okay, look at on this example from 81, and then we can obtain 27. So the complexity is now less because the number of rules is less. So that's why some researchers claim that it's good to use the HFS because it has advantage to reduce the number of rules and consequently the complexity. All right. Okay. In order to use this, I will go. They use the same function with using the same fuzzy logic system. Okay, but now they have to create for individual subsystem, right? And then the rule is now become small because each subsystem only have 2 input and 1 output. 2 input and 1 output. So the rule now become less. Okay, in compared to the standard fuzzy. All right. Okay, step 1, creating the individual subsystem. Okay, need for the hierarchical. And then now we have to load. Okay, for example, if we have three subsystem, so now we have to combine all together. Okay, in this case, I add the library of Shiny because I want to show it using the GUI, and then I have to combine all 3 together because they have fuzzy subsystem 1, subsystem 2, and subsystem 3, and then we have to put all together. Combine all the subsystem, and then we can get all the membership function, rules, and we could also evaluate 3 individual subsystem. Okay, here I just copy the interface and not showing the real in FuzzyR. Okay, just to give the idea how do we create the hierarchical using FuzzyR. All right, so the output of the HFS hierarchical system, we can also visualize using this control surface. But for this case, they can only visualize 2 input and 1 output. You cannot give 3 input because they cannot visualize this graph using 3 input. They need to use only 2 input and 1 output. All right. So the code, because I just go very fast, but we already published the code, okay, for subsystem 1, subsystem 2, subsystem 3 in this Codition. Okay, Codition is the platform where we can share our coding, okay, our code, okay, and then there has a lot of engine, whether you want to use in R, Python, MATLAB, and so on. So now, if you are interested to try and error using our code, you can have a look on this Codition. Okay, here is the link. Right. Okay, the last example. Okay, just now I showed example how we create fuzzy for iris application. Okay, another example. Okay, this paper also presented in this year. Okay, in July. All right. So how to model a hierarchical fuzzy system using for Mango grading using FuzzyR Toolkit. Okay, just a case study. Okay, if you have this picture, okay, I think it is easy to classify for the grade A. Okay, looking by looking on this picture. Also for the grade C. Okay, but however, in the between here for a grade B, so they have some uncertainty to decide. Okay, what is a grade B? Whether this one can be grade C or whether this one can also stated for the grade A. So because of this case study, okay, we also ask a few experts. Okay, expert here is we define because they have experience. Okay, they have a mango farm and also working on this area. So we give the same mango. Okay, and then we bring to expert 1, expert B, expert C, and expert 4. Okay, we give them to rate just by looking on this picture, okay, to feel and get the texture and then to give the grade. Okay, or okay, this is the case study of we test with 4 experts. They also have a subjective view of answer. Okay, this is because of the uncertainty, because human, they have how they perceive is a different between expert 1 and expert 2. Although we do have like organization, something like in Malaysia we have pharma, okay, that control the grade. So we already have some grade, but when we ask the expert, okay, the answer might have a subjective view in their answer. Okay, we already have some. We publish also this paper of how to capture grading from human expert in this last year paper. So, in this, we just to show how can we get the answer from people, get a survey of the 11th mango, and then we can get for each of these expert will have a different answer for the size, color, and skin, and the grade, and then we also access how expert different from expert 1 and expert 2 for each input variable. For the case of mango, they just only have 3 input. Okay, they have size, color, and skin. Okay, for now, from here, okay, from this fuzzy logic, the standard fuzzy, now I want to do the hierarchical. Okay, so now they have 3 input: size, color, and skin. Now the subsystem 1 only have a size and color input, okay, and then the skin will go to another subsystem, and the last one is a grading. Here is a membership function, okay, for the size example. There is a rule base for fuzzy logic system. For example, if size is small and then the color is A poor, and then Y1, we give Y1 is ABC. So ABC will stand for, by combined size and color. So what is a category? Whether they are A is a good, B medium, and then C is a bad. So we just put A, B, C, D. All right. And then they have 2 different rule base. Okay. Also, we can evaluate the fuzzy inference with FIS using the FuzzyR. Right, and then since we already have a result from the expert, okay, and then we also have a result in our FuzzyR, so we want to see, okay, standard fuzzy and hierarchical fuzzy, okay, which one is very close to expert, how expert give the grade. Okay, based on this study, okay, we can see that HFS, okay, will give a less error, okay, in comparing with the standard fuzzy for the mango grading case. Okay, right. And also we look it on the another angle. Okay, that one is accuracy, but now it is interpretable. How close? Okay, how easy we can understand the fuzzy system. Okay, fuzzy system or horizontal fuzzy system. So since we already have indices that we presented in the paper, okay, we introduce the indices just to measure the interpretability of fuzzy system. Okay, so based on this, we access the fuzzy standard fuzzy and hierarchical fuzzy for the mango grading cases. So for the higher is we said the higher is a better, is a more interpretable. More interpretable here is, for example, the number of rules. Okay, for HFS is very less compared to the fuzzy logic system. So when we put these indices and measure to the fuzzy logic system and hierarchical system, so we obtain that HFS is better than FLS for the case of mango grading example. All right. So I think that is my sharing on fuzzy logic system. That how we can generate the fuzzy logic system using a FuzzyR Toolbox. Okay. Yes, obviously this is just a surface. Okay. Maybe later on, if you guys are interested to use this FuzzyR, maybe later on, maybe you guys can contact me, and then maybe we can collaborate in future and try to, if you have a case study, and then we can try to create a fuzzy logic system maybe using fuzzy R. Right. With that, I think thank you very much all for interested. If you have any question regarding my presentation, yes, you can ask me. Maybe I can pass to the moderator.
Okay, sure. Thank you, Doctor, for the very interesting and knowledgeable fuzzy system research sharing. I would like to open the sharing session now with Dr. Tajul. If there is any question from the participants, from the audience itself. So I just open first. If anyone to have any question for Dr. Tajul. So Dr. Tajul, meaning that the R2 just now, you developed with your team, right? At the Nottingham.
Yes, Nazwan.
That's really, really interesting. Yeah. Can see our name there is wow. That's very wow.
Yeah, because I think I'm very lucky because when I start my PhD with my supervisor, John Garibaldi, they are also working on this toolbox. Okay, actually, this toolbox is not my finals, a PhD, but it's very interesting to have very good experience for me to have this kind of to participate in this toolbox, because later on we can use in future. Okay, on the other researcher also can use this toolbox. In fact, my study also one of example I use this toolbox to demonstrate my case study.
That's really good. That's really great. Okay. In the meantime, the attendance link also I provide in the chat box. So, for the e-certificate, you must fill up of the attendance list. Okay. So, is there any other question? I think we shall continue, Doctor. So we go to the announcing the winner and all the. Oh, sorry, Doctor. There is one question from Shafiq. Salam, Doctor. Can the toolbox detect the type of mango?
Okay, all right. Like harum manis or other mango. Okay, all right. Thank you very much, Shafiq, for the question. Okay, I have experience working on this toolbox. Okay, my toolbox is to identify the grade. Okay, the grade of mango, whether the grade is A, B, or C. Okay, for this case study, because my data, my rule base is more on the final result is to identify a grade A or B or C. Okay, your question is about whether we want to detect the type of mango. Okay, so maybe we need to create another rule base, okay, with the expert with certain attribute. And then with a certain attribute, we can detect what type of mango, whether they are Sala, whether they are Romanes, and so on. So maybe yes, the answer is now yes, we can. But now we have to identify what is all the parameter, the general parameter that we need to give to the fuzzy system in order to let the fuzzy detect what is a type of mango. So the parameter, the parameter could be maybe a size, a color, and maybe we can add another parameter in order to really detect what type of mango, whether they are Romanes or whether they are Sala, whether they are the Chokanat and so on. Is it answering your question, Shafiq?
Okay. So we come back with the just now. We're promoting the hands-on workshop integrating AI and computer vision in IoT. So this is the we want to know how many of you is interested on this hands-on workshop. So we would like to have your feedback or your concern regarding the workshop that we can prepare and we can give a very good experience on the workshop part. So you can scan the QR code to answer the concern, or you may give the link in the chat box also. So maybe Mr. Hafiz want to add on something on the workshop part?
Okay, actually we are planning to do a face-to-face hands-on workshop in integrating artificial intelligence and computer vision in Internet of Things. So this will be a workshop that have hands-on, face-to-face, closely related with instructors guiding you. So the AI will be integrated would be a computer vision AI. So we will be using TensorFlow Lite and TensorFlow, as well as integrating it with a web system. So we will be having a part with hardware part, and then the software part, and then also the network part. So it will be a very wholesome workshop, 1-day workshop with minimal coding, and then we will be giving you with a training kit. That is ESP32 board together with 3D printed housing, so you can build a professional looking computer vision project with IoT. So the registration fee currently is set at 350 per person, and this would include the certificate and also the kit. Okay, you do not have to bring anything. The kit will be provided to you, the hardware kit, including the housing and the materials, and then we will also be providing the breakfast and then also the lunch set and so on. So we have a pending onboard CPD hours, 6 hours. So if you are interested, you can register your interest for this hands-on workshop that will be conducted in UiTM Cawangan Perlis Computer Labs. So I think that's all. Hopefully we will be having fun integrating AI, very practical, and use about as minimal code as we can. Right. I think we pass it back to the moderator.
Okay, thank you, Mr. Hafiz. Okay, so now is the time that we are waiting for. The time to announce the winner of the interactive activities in the sharing session number 1. So the prize is we give 50 ringgit for each winner. Yeah, it's 50 ringgit for each winner. So without further ado, the winner are the 6 people: Ilyana Muhammad Ali, Shafiqah Hasim, Eddie H, Zhang Lifan, Alia Fatini Muhammad Sofi, Dian Pratama. So all these people, we have the email address. So we will contact all of you this week through your email. Okay, for the prize. All right. So now we have the winner. We come to the end of the sharing session. Before we leave, I would like to have to make 2 special requests for the organizer. The first one, please fill up the attendance list for your e-certificate from this sharing session. And we're going to have an online photography session. Okay, so therefore, I would like to request and kindly request from your side to open your web camera and ready to take picture with us. Is it okay? All right. So hopefully you can turn on your camera. Then I can take your picture together with us.
Sorry, Mr. Nazwan, maybe you can stop sharing because
Sorry.
you can
Yeah,
get
give
the
me a moment.
whole screen.
Understood. Yes. In my count, all right. In my count, 1, 2, 3. Yeah, give me a moment. I save first. We take another one. Okay, one more time. Okay, look into the camera. 1, 2, 3.